think we're ready. So where do we want to start? I keep forgetting the camera's up here. The computer's down. Get out of here, kitty. So I've got the Q&A app up and running. I'm not sure how that works. I guess try to type in a question. I have the solutions manual for your textbook. So any textbook problem we should be able to get through. I can pull up the reviews that I passed out to you all. You just have to give me a minute to do so. Also, if the Q&A thing's not working, go ahead and email your questions, because I can just see those on my phone. Looking for the reviews that I passed out to you all. Oh my goodness, what's he get? Alright. Rayhan, can we go over question 2, 4, 6, and 8 on that review packet? Okay. So are we talking about, just to make sure, 2, 4, 6, and 8 being angles between two curves, curvature, max min, and Jacobian? Or are we referring to the other review, which is the projection, velocity vector, graph the surface, find the equation? There's two reviews. One's entitled Multivariable Calculus Final Review Problems, and one's entitled Multivariable Calculus Review. Oh, there we go. Okay. Alright, so angle between two curves. Brooke, I do see your chat. I'll get to that in a second. What do you mean without solutions? Oh, I know what you mean. I know what you mean. Okay. Get out of here, kitty. So you would be talking about, all right. The extra review problems. Okay. So let's look at angle between two curves, curvature. We did that curvature we did in class. Let's look at angle between two curves first. All right. Pen. Here we go. So the angle between the diagonal of a cube and, let's say, one of its edges. So X, Y, Z, a cube, would be S by S by S. So the diagonal of a cube, let's look at that one. Or let's maybe reorient my axes. Okay, let's look at this diagonal here and this edge here, so we want that angle. This will be the positive y-axis, positive x, and this will be positive z. Give me a second, I need to take care of the situation. You guys need to go out there. You need to go out there. Okay. Cosine of theta equals u dot v over the magnitude of u times the magnitude of V. Okay? So let's see. Let's make this a simple cube. The angle's not going to change with respect to the size of the cube. So let's make it 1 by 1 by 1. Then the vector u will be 1, 0, 0. And the vector v will be 1, 1, 1. Righto? So u dot v, 1 times 1 is 1, plus 0 plus 0. The magnitude of u is 1, and the magnitude of v is what, the square root of 3? Let's just double check. Okay, so cosine theta equals 1 over the square root of 3, or the arc cosine of 1 over the square root of 3 equals the angle between. Can't remember what that is off the top of my head. Is it something? I don't think it's something that's widely known. The inverse cosine of 1 over the square root of 3 54.736. Okay. So angle between curves, if we want to generalize this to the angle between curves at some intersection or some point, you could find a tangential vector. So this was using just vectors, but say we had curves like a parabola and another parabola, and we wanted to know the angle between, we could get a vector that is tangential there and do a similar thing. And then the same would apply for curves in free space. You could come up with a tangential vector at a point and use this formula here. Oh, I keep forgetting to mention, you are allowed a 5x8 note card for this final exam instead of 3x5. So get one of those big old note cards. Now, if you don't have any 5x8 note cards, I will allow a half sheet of computer paper, because it's 5.5, or it's 8.5 by, is it 8.5 by 11, or 11, 8.5 by 11. That sounds right. So if you just fold it in half, I would prefer the note card. I would prefer the note card because it's smaller by a little bit. But let's see. So that was that. Okay, 2. Brooke, I'm still unsure what problem you want me to do? Number 22 without solutions. There is no 22 without solutions. Oh, I guess it doesn't have solutions, but it has answers. Okay, I see. Number 22 is use Lagrange multipliers to find three positive numbers using whose sum is 33 and whose product is a maximum. Let's see. So we want to, is that for me? Okay, never mind. All right. Lagrange. So we want to maximize the product? No. Three positive numbers whose sum is 33 and whose product is a maximum. So we want to maximize this using the constraint this. Okay. Right. All right. Del F is going to be YZ, XZ, XY. Del G is going to be 1, 1, 1. So we want Y, Z, and we have X plus Y plus Z must be 33. All right, so why don't we solve each of these for like Y, X, or Z, X, Y, but that doesn't help me. I could solve this for X and this for X, or excuse me, I could solve this for Z and this for Y. That would give me an X and an X, but also a lambda. Alright, let's just give that a try. Well, we could say that all three of these things have to equal each other. So yz equals xz equals xy. And then could we say this? And then perhaps this? And then how about dang. Hey, Kelsey? Would it be possible for you to entertain the cats? Like, just take them in there.
Rita, come here.
Get out of here. Go away.
There's one in there.
Okay, yes. Sorry about that. I had to deal with a cat issue. Okay. So let's see. Well, let's try this. I don't know if this is going to help, but if we divide both sides here by y, x over y plus y over y plus z over y equals 33 over y, and that's 1, and that's 1, which is 2. So let's subtract 2 from this side, which would be 2y over y. So what do I have? Z over y equals 33 minus 2y over y. You've got it, can't be kitties. But that still doesn't help me. Get yz equals 33 y minus 2y squared, and that's lambda. Let's see. It's, I'm not sure. Alright. I know. Alright guys, let's see. Okay, cool. Let's try something else. We could say this is y equals lambda over z. Z is lambda over x, and y is lambda over x. No, I don't want that. I want x is lambda over y. It doesn't really help me. That's supposed to be our answer, so let's see. Okay. You are so distracting. You need to not be in here. Let's see. Well, I don't want to spend the entire review on this problem. I would love if some other people could come. If anybody has any ideas, shoot me a message. I'd like to look at some other things and then come back to this. Let's do this. Let's solve these both for x. So these two things have to equal each other. And since the tops are the same, the denominators have to be the same. That should help. So we could change this to 2y equals lambda. We could change this to xy y is lambda over 2. We could say that z is y. We could say that x is lambda over y. Which is that. Which is 2. And y is lambda over 2. So is this lambda? So lambda must be 31. I don't buy it. Oh. Oh no. Let's try this again. If x is lambda over y, and y is lambda over 2, then lambda over 2 is 2. Y we said was lambda over 2, and z and y are the same, so it has to be lambda over 2. And that's just lambda. And 33 minus 2 is 31. But I don't see how lambda could be 31 if my answers have to end up being 11, 11, and 1. Okay. Alright guys, I'm sorry I can't figure this out. I thought I had something here, but I don't think that lambda could be 31 because that would make y and not an integer. And 15 and a half. So I'm going to see if there's something else that we can look at and then come back to this later, because I don't want to spend the whole time thinking about this and us not get to anything else. Let's see. Cole says x equals y equals z, so they're all 11. And that would make sense, but how are we getting that answer mathematically without just, I mean, it makes sense. Why does x equal y equals z? we could show that x equals y equals z, then I would agree with you. The closest I got to that was that. Let's see. Z equals lambda over x, or, yeah. And let's look at this. Y equals lambda over x. So lambda over x times x over z. And z is lambda over x, or x. It's killing my noggin. I could show somehow that that's equal to z, I'd be happy. All right. That answer makes sense. I'm not sure about the solution. You don't need to solve all three at the same time. Set 1 and 2 equal to each other. So x equals y. Set 1 and 3 equal to each other. So z equals x. So yz equals xz. So y equals x. Then these two, yz equals xy. So z equals x. And then these two, xz equals xy. So z equals y. So they all have to be equal to each other. Okay, I'll buy that. So then you just say 3x equals 33, so x has to be 11. They all have to be 11. That's much simpler. Oh man. Thank you, Cole. I don't know what I'm going to do next year without you. All right, let's look at some other questions. I'm so sorry that the door got swung ajar. That was my cat. Alright, let's go back and look at Rayhan asked about 2, 4. We did 4 in class. We also did 6 in class, didn't we? 6 was another Lagrange, and we did 8. Are those the ones you're talking about, Rayhan? Moments in center of mass. Moments in center of mass. Let's see. I believe you do. Oh, actually, no. I don't see any moments or center of mass on the final, on either part. So, no moments or center of mass.
I think Steve just left.
Good.
Did you ever talk to him?
No. So, whatever.
He's the lecturer here. So.
Yeah. If he wants something, he's got my number. Alright, so let's see. Anything else? How about I go through here? What about chain rule? Do we remember chain rule? That would be chain rule. So let's say we had a function z of x, y, and both x and y are functions of t. Right? And now I want to find dz dt. So I want to find the derivative of z with respect to the parameters, right? So chain rule. Want the partial of z with respect to x times the derivative of the inside. So that's dx dt. Okay, plus the partial of y with respect, the partial of z with respect to y times the derivative of the inside, right? And so that would be the formula. So partial of z with respect to x, we're looking at 2xy times 2t. Plus x squared times 3t squared, and then going back through and plugging in t values for these, 2t to the fifth times 2t plus t to the fourth, 3t squared, or 4t, that's a t, not a z, t to the sixth plus 3t to the sixth. What's that? 7t to the sixth. That's an interesting 7. Right, and of course we could do this with 3 variables. It would just be dz, or the partial of z with respect to w, plus the derivative of w with respect to t. Where it gets tricky is when I have, let's see, say I have a function of 2 variables. And each x and y is a function of 2 variables. And I can't find a derivative, but I can find a partial derivative. So I could find a partial of z with respect to u and a partial of z with respect to v. And we'd be looking at the partial of z with respect to x times the partial of x with respect to u plus the partial of y with respect, partial of z with respect to y times the partial of y with respect to u. The only thing that changed from here down to there, the u's turn into v's. And obviously that could be a function of 3 variables. This could be a function of 3 variables, but for your test, the first example would be more closely resembling something. Let's see, any other questions yet? Rayhan, we didn't get to 4 in class. Alright, Rayhan, curvature. Find the curvature with t equals 1 and the tangential component with t equals 1, the tangential component with t equals 1, and the normal component with t equals 1. I think we did find the curvature, but we did not find the tangential component and the normal component. It is. I'm gonna kill him. I'm gonna string him up. I am.
Where are they?
The cats?
Oh, there's one. Oh, I see them right here.
873. All right. For the problem, number 4, TT squared 3T.
I think this cat is blind.
T squared 3T. I'm just going to say that the curvature is the absolute value, the magnitude of R double prime cross R prime over, R prime cross R double prime, because remember those are going to be different, over the magnitude of R prime cubed. Since the curve I got is parametrically defined, this would be a much easier formula to use than to try to find, what is it, D, big D, big T, yeah. Okay, 2 different formulas. This is going to be the easiest one. It's pretty straightforward. First derivative, second derivative, cross them. First derivative, cube it. But you're not cubing the first derivative. You're cubing its magnitude, right? You should be getting a scalar out of that and then cubing the scalar. The 2 parts we didn't get to were the tangential components and the normal components. So let's see, the tangential component, large T, is R prime over the magnitude of R prime. So tangential component will be 1, 2T, 3 over the magnitude of 1, 2T, 3. Let's see, the magnitude of this is 1 squared plus 2T, make it a 4. So we get the square root of 4T squared plus 10. One over this times that, or preferably 4T squared plus 10, comma, right, then we wanted this at 1, so 1 over the square root of 14. 2 over the square root of 14, 3 over the square root of 14. course, you could rationalize those. Not 100% necessary. Okay, then the normal component is the tough one because you got to find the binormal first. Oh no, the normal. Well, it depends. If you have your curvature, you can get the normal with respect to arc length if you already have the curvature. But I think what's going to be simpler for us is with respect to t, which is the binormal cross the tangential. You've got to be kidding me. Go away. Go away. You're going to get a beat down.
I can't keep him down.
Okay. So let's do this. A binormal is the magnitude of r. Nope. Just r of t cross r double prime. R prime cross r double prime over that magnitude. Okay. Let's see, r prime. Do we have r prime? Yeah, r prime is here. So r prime is 1, 2t, 3, r double prime, 0, 2, 0. That cross product, 1, 2t, 3, 0, 2, 0. It's going to be 0 minus 6, I minus 0 minus 0, j plus 2 minus 0, k. So negative 6i, 2k. So negative 6, 0, 2 over the magnitude of that, which is going to be 36 plus 4, square root of 40. Okay. So we want to cross this and that. So you would do your I, your J, your K with 1 over the square root of 14, 2 over the square root of 14, 3 over the square root of 14, and negative 6 over the square root of 40. 0 or 1. 0. 2 over the square root of 40 would be your normal. I'm not going to do that right now. Okay, it sounded like I got something in. Number 2, the one on projections. Yes. Hello, River.
Previously
let V find the projection of, what is that? V unto U or U unto V? Let's see. Go away. Vector projections. Vector projections. By the way, guys, I'm using a different multivariable textbook than the one we use because I left mine at school. That's why it's taking me so long to find things. Vector. What about projections? Why is this not in here? Oh, that's why, because it's a different chapter. That's it. Found it. Okay. The projection, orthogonal projection of V on an arbitrary non-zero vector B can be obtained by that or that. So, alright, so down, just to let you know, I don't know if you were here earlier when I said this, I keep forgetting to put it in the announcement. 5x8, no card is going to be allowed. So this would be something to have on there. V dot B over the magnitude of B squared times B. And that is the projection of V onto B. All right. So we want U to be 3, -1, -2. And V is -2, -3, 2. And we want U onto V. So let me go and change all my V's to U's and B's to V's. All right. So U dot V, -6 plus 3 minus 4 over the magnitude of V is the square root of 4 plus 9 plus 4 is 8 and 9, 17 times the vector V. All right, and what do we have here? -10, is that 7? Is that the answer? Yes. Oh, but my signs are all different. My signs are all opposite. I wonder why. Did I do my dot product? That's negative. It's positive. That's negative. Oh, that's -7. So that would make it right. 14 over the square root of 17, comma 21 over the square root of 17, comma 14 over the square root of 17. Okay, cool. Let's see, anything else? I get any other emails? Okay. Michelle, will tomorrow be the calculator or non-calculator portion? So here's my thinking. I was going to do tomorrow as the calculator portion, and then Wednesday as the non-calculator portion. But then Wednesday I would allow you to go back to your calculator portion without using a calculator. Does that make sense? Nod your head if it makes sense. I can't see. The contingency for You gotta be kidding. Prince William County Schools closed. Kelsey, did you hear? Brian just said Prince William County schools are closed. Yep. His wife works for Prince William County. I know, but they're a bunch of pansies, so. Number 9 on parameterizing. Yes. He said it's official. Let's see, number 9. Find the parametric equation for the line through the endpoints through the point that and parallel to the line that. Okay. Find a parametric equation for the line through that point parallel to that point. Parallel to the line that. So let's see. I might be pulling this out of my butt, but let's see. If I'm not mistaken, that symmetric equation implies that x over 1 equals t, y minus 2 over 2, and z plus 1 over 5, y minus 2 over 2, and z, that's not right, y minus 2 over 2 and z plus 1 over 5, y minus 2 over 2 and z plus 1 over 5, all equal t, in which case x would be t, y minus 2 is 2t, z plus 1 equals 5t, and so I have the parametric equation for a line x equals t, y equals 2t plus 2, and z equals 5t minus 1. So I want to be parallel to this and go through the point, where was I? 4 negative, and go through the point 4 negative 1 3. Okay, well, just the long way to think about this is you would want then dx dt, which is 1, dy dt, right, which is 2. We're just talking about the coefficients of t in this case. So I could quickly write my new equation. X minus 4 equals t, y minus negative 1 equals 2t, and z minus 3 equals 5t. So that will be parallel to this, but go through that point. I think the online solution had a typo here. So this would be it. Okay. Done. Oh, I got some chats up here. It's okay. It should get in. Just to be clear, because I just saw this from Brooke, I don't believe there's anything about moments or centroids or lamina. We're really looking at, let's see, there's a lot of stuff from the last two units. So a lot of Stokes theorem, a lot of divergence theorem, triple integrals to find volumes, describing level curves, so that kind of stuff. That chain rule stuff that I showed at the beginning, that's on there a few times, various forms. Let's see. Relative extrema, saddle points. So have that on your note card. Limits. Right, limits of a function of more than one variable. So limits of functions of two variables. Surface area. So being able to find the Jacobian, if you were to have to say evaluate an integral using a given transformation, right? There's one Lagrange on there. And I'll be really nice and say that the Lagrange problem that's on the test is very, very similar to the Lagrange problem that we did earlier. Very similar. Directional derivative. Find a unit tangent vector. That's not too bad. Evaluate a line integral. Obviously, there's a shortcut, right? You can evaluate a line integral using the fundamental theorem of line integrals if the field is conservative, and field is conservative if partial of q with respect to x is equal to the partial of p with respect to x. If that's the case, then fundamental theorem of line integrals is the way to go. and then Green's theorem again. So a lot of what we saw in the last few units. I'm going to check to see if there's any other questions via email or anywhere else. I don't see any. But if that's the case, then we will call it a day, or a night, really. So I'll go ahead and share with you guys my thoughts on what's going to happen if we have snow cancellation tomorrow. If there is no snow tomorrow, that means you have 1 day to take a final that's supposed to take 2 days. So I will cut it in half and say that you have to complete 5 of the 10 calculator problems and 5 of the 10 non-calculator problems, your choice. So 10 problems total. It kind of cuts it in half without me having to eliminate. Really, it was tough to eliminate any of the problems without eliminating entire sections. I guess the only thing that's really not represented on there is moments of centers of mass, and moments. But those are really applications of integration, and really more of a physics topic, I guess. The sorts of things that you can expect to see on this test won't be application type things. They'll be the very mathy, very theoretical, conceptual based kinds of things. Computation, that kind of stuff. So again, I think that's going to be it for today. If snow occurs, we're going to cut the test in half, and it's your choice. You do 10 out of the 20 and 1 of the bonus questions. There are 2 bonus questions. You do 1, and we'll go over how that sort of will be submitted, because you'll have to tell me which problems you're doing somehow. And yeah, we'll figure it out. No worries. Like I said, I had a plan. That's what it is. So, all right.